This conference will now be recorded.
Back. Hello everyone, once again. So welcome to the introductory session for Azure Admin and DevOps course. So before jumping right into the subject, let me introduce myself. So my name is Kiran. I have 8+ years of experience when it comes to DevOps and cloud. I have worked with various tools like Terraform, Helm templates, Bicep, Docker, Kubernetes, basically everything related to cloud and DevOps. And I've trained a lot of engineers and a lot of beginners who doesn't really have knowledge about IT and everything. So I've trained a lot of people to get into DevOps and let's say cloud. So that's about myself, and these are some of the certifications that I have to prove my credentiality. So this is a very brief about myself. So I'll just take a pause in here for folks to introduce themselves to the class. Just give a brief introduction about themselves and what are the expectations from this course. So any volunteers? Anyone wants to go ahead and introduce themselves to the class? Before we get started with the subject. You can just unmute your mic and just introduce yourself, give a brief description. Okay, what are your expectations from the course, so that we can lay down a foundation. Okay, what set expectations and all. Yeah, I can see someone unmuting themselves. Yeah, please go ahead.
Yeah, hello everyone. This is
Hello.
Mona Avila, and I'm graduated in Electronics and Communication Engineering.
Okay.
Actually, this is my first ever tech training program.
Mm-hmm.
And so I'm excited as well as a bit nervous too to dive into something new.
Okay.
Yeah, I'm
Cool.
looking forward to growing technical knowledge and explore career opportunities in it as well.
Awesome. Yeah, great to know that.
Yeah, thank you.
Welcome, Mona, to this class. Yeah. Anyone else?
Hi, myself
Yeah.
Karunakar.
Hi,
I
Karan.
have hi 15 plus experience in a
Mm-hmm.
we are a product based company.
Okay.
I have 15 plus experience. I used to have 9 years of experience in testing. Right now I
Mm-hmm.
am into delivery. So
Okay.
just I want to update myself into everything
Mm-hmm.
that comes to me. That's it.
Yeah.
That's the expectation.
Yeah, cool. Thank you. Yeah, that's, let's say, broad introduction, and good to have people introduce themselves. Now, don't get, let's say, if someone is joining for the first time, doesn't really have any software experience, I would guarantee that this starts, whatever this course is, it starts from scratch. Basic from, okay, what exactly is a machine? We'll start from that and go and try to understand very complex concepts in a very simple manner. That's the expectation. So don't get confused or bogged down that okay, there are people who have experience and all that. So we'll keep it simple and try to focus on learning of everyone. So it's not like okay, I will be targeting a person who has experience or doesn't have person. Doesn't really matter. So anyone with, let's say, minimum knowledge, I would say no knowledge as well, that's absolutely fine. This course is curated in such a way that anyone can understand. So that's the expectations from my end. Now let's get started with the course itself. So this, as it isn't as this is the introductory session, I'll keep things very simple and try to understand why exactly what is the purpose of DevOps? Why did we even move to DevOps? So we'll try to understand the problem and try to tackle it and get a sense of it. So first, let's say there is a person. Let me take an example. Let's say there is this person called Ram. So Ram, this person is a business oriented person. This person has an idea that he wants to host an application like Book My Show. What is the purpose of Book My Show? Like similar application like Book My Show. Let's make it interactive. So anyone, what is the purpose of let's say Book My Show application? Anyone? Why do we use Book My Show? So basically, it is a business where people can book tickets. It enables me to book tickets from wherever I want, wherever I'm. So I can just go ahead, open their website, give my credentials, and book a ticket. Let's say Ram has similar idea, and this person wants to do that. So what's the most important thing in this business? Let's say in this, let's say, application or whatever it is, what's the most important thing? There needs to be a website, right? So where if I want to book a ticket via Book My Show, I just type in bookmyshow.in and I'll be able to book tickets. That's the first thing. But Ram is from business background. He doesn't have really any experience related to how to manage a website, how to do all of that. He's from business point of perspective. Just give me a second. Yeah. So this person is from business background who doesn't have knowledge of okay, how to maintain a website and all that. So what he knew that to maintain this website and all that, there needs to be something called as a web application. This is a mandatory thing. So without a web application, we cannot really maintain a website. Whatever website you take, Amazon.in or even Book My Show, Flipkart, whatever it might be, there needs to be something called as a web application that needs to be in place. So this is the first thing. But as this person is from business background, he doesn't know, or let's say, how to build a web application or how to maintain and do all of that. That's where this person will go ahead and hire some professionals or experts who have knowledge and experience in building this web application. Just like if you have some money and have a goal of constructing a house, you don't go ahead and construct the house. What do? You give the money to civil engineer, and that civil engineer will assemble a labor and everything to construct the home for you. You just pay the bill that okay, this is the charges that person has taken, and you pay the bill. Now that's the scenario. Now what this person will go ahead and do, this person will go ahead and take help of, let's say, developers. So there are software engineers specifically called as developers who know how to build this web applications using some languages like Python. So there are languages, Python, C Sharp, there are a lot of languages out there that help them to develop this web application. So what's going to happen, this person will hire these developers and hire them based on the monthly salary, like 50,000, whatever is their experience. He goes ahead and hire these people and give them, or they give his requirements that okay, I need an application like Book My Show where people can log in and book tickets, make payments. So this requirements will be given to the developers, and developers will take their time to develop the application using any language. We'll just say Python or whatever it is. So they have developed the application. Let's just say it took 1 month for them to develop the application. Cool. Now, how can okay, the application is up and running, looks great. Now, how can I take it to the end user? As in, we are the end users, right? If you look at Book My Show kind of application, we will be logging into Book My Show and book tickets. We are the customers. So the product is ready, the application is ready. Now, how can I take this application to the end user such a way that they can, let's say, log in and book tickets, make payments, and do all of that? How can I take this to the end user? Let's say this is the end user, but whatever web application that's been developed, where exactly it is situated at this point in time, or where exactly it is running on the developer's machine. As in, whoever has created that, they will be having their machine, right? As in a laptop or personal computer, whatever it is, this application is running on that machine. Anyone who has access to that machine can only access the application. As simple as it gets. So now if someone wants to book a ticket, they need to get an access to this machine, and there might be multiple machines. It's not that one developer will be working on this application. There might be 10 developers, let's say 10 developers who has developed this application, and 10 machines are in place. Now how can, let's say, this user access this web application? They need that laptop physically. I mean, these developers might be sitting in Hyderabad, this person might be from Bangalore. Now how can these people, I mean, how can this person go from Bangalore to Hyderabad just to book a ticket to access this application? That's not practical, right? Now, okay, you might say, okay, if that person is in Hyderabad and close to the office, yes, they can go ahead and access the application. But if that's the case, then I can go to theater and book the same tickets. Why do I have to go to this person's office, get the developer's machine and give my credentials and do that? I can simply go to theater and do the same thing. Now, this problem is called as developers machines issue, where the application has been built, but it is not exposed to in such a way that the end users cannot really access it. So what needs to be done in here is, so this is the problem we have to understand. So as of now, the application is up and running, looks great, but the problem is how exactly this application can be taken to the end user in such a way that how can I take it to the end user so that they can just access it anytime at any given point in time they can access it. So what can I do is instead of running my application on the developer's machine, simple thing is instead of running this, what I do is I replace that developer's machines with something called as a server. So what exactly is server? I'm pretty sure you might have heard of this term called a server. When you go to other, let's say Bicep or whatever it is, you just go and tell them, okay, I want to update something. They might say, okay, server is down, something like that. So this is the server that is the server that you're talking about. Now, what is the server? So server, in simple terms, it is also another computer. Another computer, or you can think it as a supercomputer. The reason why I am calling it supercomputer, if you look at the specifications, if I ask you what are the specifications of your laptop, you might say it starts from 8 GB of RAM. These are the specifications of normal laptop that we use daily, correct? And it might have 1 TB of storage. These are the specifications that are enough to do our regular job. Now, what about if you take this server, which is also a computer at the end of the day, but if you look at the specifications for this server, it might start from, let's say, 32 GB or 62 GB or even 128 GB, 256 GB based on your requirement. I'm talking about RAM, so it might have that level of, let's say, RAM, and along with that we can look at, let's say, 10 TB of storage, 100 TB of storage, because it has to serve a lot of requests. So whatever I want to do, what basically, if you look at any application, it is basically running on something called as this server, which is a supercomputer which can take or process a lot of requests. So that's the definition of server. So don't get confused. Okay, what exactly is server? Server, you can think it as a supercomputer. So this is how I've just given some diagrams over here, and there can be other forms of let's say servers as well. This is one example. Now I have my servers. Now instead of running my application on individual developer's machine, where I have to parcel, okay, instead of the end user coming to my place, or else I can send the developers machines to their place as well. But that's impractical, right? If I want to send a request to, if let's say someone wants to access it from Bangalore, I have to ship my developer's machine to Bangalore. If one person is trying to access it from Chennai, I have to send it to Chennai. So that's not practical at all. That's going to cost me a lot. I mean, cost RAM a lot. So that's another problem that we have. So that's why we have introduced this server, and instead of running this application on developer's machine, what we have done, we are running this application on top of this server now. Now, once we start running our application on server instead of our developer's machine, what really happens is that it is exposed to the internet. Now, anyone on the internet can directly access this application that is running on the server with the help of internet. So if you do not have internet, you will not be able to access it. So same concept, if internet is down, you cannot really access any website. In the same way, now I'm running this bookmark show application on top of this web server, or server to be precise. Now anyone on the internet will be able to access this application. So this way, now there is no concept of sending the lab developer's machine to the end user, and that problem will be solved. So this basically solved the developer's machines issue. So far, any doubts, guys, or any clarity required? All right. Okay, assume everyone is on board. Now, what's the problem? Okay, everything looks great. The application has been built in 1 month and it has been running on server. Everyone on the internet can access it. Now, what's the problem? So there are a couple of problems we have to address. So what are the problem? So the problem is the server itself. So we have a lot of problems with this server itself. Let's try to tackle, okay, what is this? What are the problems around with server? So first problem is something called as capital expenditure, as in it's a computer, right? It's a computer. That means you have to spend some money. It's a product at the end of the day. Now you would need some money to purchase it. So what about the purchase power? Like how much does a typical server cost? So let me take my board. So our normal laptops, how much it might cost us? If we take our normal laptop, which has 8 GB of RAM, 8 GB of RAM and also that's a 1 TB of storage. If these are the specs, it might cost us, let's say, around 50K. Normal, I'm just giving some ideal numbers. Now, if I want to buy a server, purchase a server, it might, let's say, the specification might start from, let's say, 32 GB, and 100 TB of storage, and this might cost me around 2 lakhs. Let's go with 2 lakhs. So this is not cheap. So that's the first thing that I have to keep in mind. I mean, 50K, if you have it, you can just go ahead and purchase it. But let's say clubbing or getting 2 lakhs is a problem for most of us. So it's a problem, right? For most of, let's say, people, it's a problem. Let's say getting 2 lakhs to purchase something, it takes some planning and all that. Now, okay, you have arranged money from your, if you do not have, you have taken loan, or from your friends and family, you have, let's say, accumulated 2 lakhs of rupees. Okay, that's one problem. So you have solved that problem. But the first problem is you need money to purchase that server. Without money, you cannot really purchase the server and you cannot expose it to the internet. So that's the problem. So first is you need 2 lakhs of rupees to purchase the server. Now, is that it? Okay, now I have 2 lakhs. Is that it? Does that solve all the problems that comes with server? No. There is one more problem. So if I want to purchase a laptop, where can I go? I can go to, let's say, Reliance store, Dell HP showroom and all that. And within, let's say, 1 hour or 2 hours, if I'm sure about what laptop I need, I can get it within no time. Within a day or so, I can, even if you order it on Amazon, it would take 1 or 2 to ship it. That's it. Now, if I want to get a server, most of them would take time. It's not that, okay, it's a finished product. You need to give them the specifications and they will curate and get you the server, and it's going to take some time. It's not like straightforward within a day or so. You would get that server. So most of these companies would be abroad. So there would be a lot of customs and all that. So it's really difficult to get it on time. So let's say there is waiting period as well. So you would need some waiting time. You need to wait some time to get those servers delivered to your place. So let's say how much time it would take. Well, it might go up to, let's say, 4 weeks, depending on from which place or which country you have placed the order. So it might go up to, let's say, 1 month. Let's take ideal time as 1 month to get that server delivered. So first thing is you would need the money, and then you still have to, okay, if you have the money, is that it? No, you have to still wait for the server to get it delivered. So it would take 1 month, or in some cases 2 months or 3 months, and within that time other competitor with similar idea can go online and they can, let's say, generate the revenue. So it's important you get the timing correct. So second problem is waiting period. Okay, now, okay, I have the 2 lakh, I have let's say accumulated 2 lakhs of 2 lakhs rupees of money and waited for 1 month to get my server delivered. Is that it? No. I still have to tackle one more problem, that is maintenance. What is this maintenance or maintenance cost? I would say maintenance cost. Okay, once we have the server delivered, is that it? It's going to run on its own? No. You would need you would need electricity. That's one thing. And you would need cooling systems, or let's say ACs and all. Why do we need ACs and all that? Why can't I just go ahead and run this server? The problem is that servers run at very high speeds. Like if you take your laptop and open a lot of applications, what really happens, your whatever cooling fans you have, those might be sufficient to run your laptop at optimal speed, and it's not going to, and even if you see, it gets a lot of heat, it generates a lot of heat. If you look at a server, and if you do not control the surrounding temperature, it might impact the server's performance. So that's why if you look at any server, let's say server room and all that, it would be air conditioned. There needs to be a specific temperature that needs to be controlled. So if you do not have that system in place, you have to purchase those ACs, make sure the surrounding temperature is controlled, let's say 22 degrees or whatever it is, or 16 degrees, it has to be controlled. So you have to bear the cost of those ACs and purchasing the ACs or whatever the cooling systems, and pay the electricity bill for them, and also the internet bill. So you have to do this every month. Let's say it's not that, okay, internet would be free for now, and after some time it would be priced, and you have to do this every month. So let's say it would cost me 10,000 rupees every month. So 10,000 rupees every month. So you have already spent 2 lakhs to purchase the server, and now you're spending 10,000 rupees every month to maintain that server. So this is the second problem. where you have to take care of maintenance. And I haven't discussed about, okay, where to place this server. So usually we don't place it in our offices or in our, let's say, living room or something. You have to place them in a dedicated room where the temperature can be controlled and all those. So I'm just putting all of them together called as maintenance cost. Then we have the last problem, that is maintain. As we own the server, we have to take care of updates and upgrades. So if there is a new security patch or new security update that's been given to the server or the operating system, we have to make sure, okay, it's been installed on the server. So what happens if I don't install the security update? It has a high chance of getting hacked. So the data can be lost and a lot of other factors. So it's important that I always try to maintain the latest security updates and just make sure we have everything in place. So just like your laptop or your smartphone gets updates on monthly basis or whatever it is, the similar way we have to make sure our server runs on the latest security patch or whatever other updates we have. Otherwise, we'll run into issues. So these are the problems that we have. So what are those? So first is we have, so just go back. So first we have the problem with capital expenditure, then we have to wait for some time to get that server delivered. And up next, we have to take care of the maintenance. And the last one being updates and upgrades. As we own the server, we have to take care of updates and upgrades as well. So these are some of the problems that we have with server. So any questions still here, guys? All right. Okay, we have discussed the problems that we have with server. Now let's go ahead and try to understand what exactly is the solution. So what's the solution to this problem? So the solution to this is where the solution is not given by, let's say, a person or something. This has come from some companies. So there are big companies like Microsoft, Amazon, Google. These are biggest companies, biggest names in the world. They have seen this problem that, okay, people are unable to purchase servers. They are waiting, let's say, spending a lot of time in waiting those servers to be get delivered. And even if they have delivered, they are, let's say, not able to maintain those servers and all that. They have seen this problem. Now what they have done is they have a lot of money with them because they are billion-dollar companies. They have, let's say, a lot of influence as well. What they have done is they have used this power and, let's say, money to purchase this server. What they have come up, they have come up with a plan that, okay, I see you do not have money to, let's purchase a server. What they have let's say mentioned is, we will go ahead purchase this server because they have. And how many servers they purchase? One or two? No, they purchase, let's say, in the scale of thousands or even lakhs of servers will be purchased, as they have dealings with the biggest server companies like Dell, HP, whatever it is. They have their power and influence. They use them and get them delivered on time, set them on some place, and make sure they are up and running. And as they own these servers, they will be taking care of, I mean, capital expenditure. They will go ahead and make the initial investment of purchasing those servers. And as they own it, they have the influence. They don't have to wait that long as we do. And then it also tackles the maintenance cost. As they maintain it, they maintain bulk, it's going to cost them a very less, and they will take care of that maintenance as well. And as they own those servers, they will also take care of updates and updates. Basically, whatever problems that you've discussed so far, everything will be maintained, or they will be managing it. It's just like saying, okay, your goal, I'll just give an example in here. So if you move to Hyderabad and you do not have any friends and family, so what's your goal? You need a place to stay. Like you have a work of, let's say, 7 days, you have the option of you need a place to stay. So what you do, you either go to, let's say, and you rent an apartment and do everything, rent an apartment and stay for 1 week or 1 month till your work gets done and pay the rent, right? And do you own that apartment? No, you are just renting that apartment for your need. Your need is to run or to stay there for some time. That's your goal. You don't bother about, okay, whether you own that apartment or not. It's not a matter of concern. Your goal is to get a place and stay for some time, and once that's done, you just pay the let's say services cost and all that, you move on. So same way, what you do is, in this manner, in this problem, what these companies have come up with the solution is that you don't have to purchase the servers and do anything. We will do it. We will maintain everything. You can use our servers by paying some cost, because, I mean, at the end of the day, it's business. You would need. And now, how the question is, how can I use their servers? They might be creating these servers or maintaining these servers somewhere in United States or England, whatever it is. Now, how can I, let's say, use their servers? In order to use their servers, I just need an active internet, and then I would just need a laptop. You can also access their servers on, be it mobile, tablet, whatever. For simplicity, I've put a laptop in here. So this, turn on the pen. So these servers are now given for rent. So you can think these servers are given for rent, and how do I access these servers which are given for rent? Over the internet. If I have active internet and a laptop, I'll be able to run my application. Now I don't bother about, okay, what's the server that on which my application is running. Even if you look at any application that you are working or that you interact with daily, let's book my show, Amazon, whatever it is, you don't bother about, okay, whether this application is hosted on the Amazon servers or Flipkart servers. You don't bother about. What you bother about, whether the application is up and running and whether you are able to place an order, make purchase, and all that. That's your goal. So you don't bother about where that server is and all that. So same process will be used. What's the goal of RAM? RAM's goal is to run an application on top of a server so that everyone on the internet can be able to access it. So now these servers are nothing but, so the fancy name called as cloud. So these servers that are given for rent are called as, is nothing but cloud. So whatever servers that are given for, let's say, rent, this concept is called as cloud. So if I have to give a very simple example for cloud, it's someone else's computer. At the end of the day, it's a server. So what exactly is server? It boils down to a computer, right? So it's someone else's computer that we are taking for rent. That's been taken for rent. That's it. That whole concept is called as cloud. And people generally have a misconception that, okay, if I say I'm storing something on cloud, I mean, they'll think of, okay, I'm storing it on the sky cloud and all that. No, there is no concept of storing it on sky and all that. There is no concept of such. So whatever it is, there needs to be a computer on which I'll be storing my data or do anything. I need a computer. Whether I own it or not, that's where this term called as cloud has been coined. So that is about cloud. So what exactly is cloud? Cloud is nothing but someone else's computer that's been given for my usage. And as I'm using their server for my usage, I have to pay the bill. So whatever service cost, I have to pay at the end of the month. Let's get back. Now, there is one more term called as cloud computing. So what is this cloud computing? Cloud computing is nothing but it's delivery of the computing services. Let's not focus on storage, database, and all that. The important phrase to note in here is over the internet. So this cloud, whatever the servers that are available for rent, how do I access them? I access them over the internet. Without internet, I'll not be able to access their servers, which might be located in, let's say, England or United States or even in Bombay or whatever it is. How can I access them anywhere from the world? Because of the internet. That whole concept is called as cloud computing. I'm using their servers to run my applications or store some data, whatever might be the use case. I'm taking their services for rent. So that's why it is called as cloud computing. So what are the benefits that I get over maintaining my own server? So let's look at the benefits. First thing is on demand. So what exactly does what do I mean by on demand? So on demand, as in, let's say I have taken a server. If I have a server which has specifications like 32 GB of RAM. Let's take one metric, 32 GB of RAM, which can hold up to 100 requests per minute. Let's just think that. So it can serve up to 100 requests per minute. Now, let's say there is a big movie that's getting released, pan-India movie, whatever it is. Now, the spike, people are trying to book tickets for that, and 32 GB can handle, let's say, 100 requests per minute. But as this is a big movie, there are 200 requests that are coming in. Now, it cannot really handle this 200 requests, and you might have seen when the big movie is getting released, the homepage of Book My Show might get crashed, and you might have seen Book My Show obviously gets crashed because of the load that's coming up. So because let's say if I'm maintaining my own server, I have to purchase one more server so that it can take up this load, so that I can distribute the load extra 100 requests to other server with 32 GB. But if I want to get another server with let's say these specifications, I have to go through the entire cycle of, okay, I have to first accumulate 2 lakhs of rupees and then wait for 1 month and next 1 month to get that server delivered. Within that 1 month, that movie will be on OTT as well. So you're potentially losing revenue. So that's very important to understand. So now I cannot really create these servers or get those servers on demand. But if I move to cloud, I can create one more server with this specification within, let's say, 5 minutes, or not even 5 minutes, within 1 minute. I can create one more server. I don't have to wait for 1 month to get it delivered and then do all of things. I don't have to do it. Everything is managed by cloud. I just have to click some buttons and create one more server. It's just like ordering something on Amazon or, let's say, Flipkart. It's as simple as that. So it is on demand. So based on my demand, I can create one more server. Okay, what if that movie has been released, now the traffic has come down? I can go ahead and delete it. So it's not going to let's say take a lot of time. Within, let's say, 30 seconds, that server will be deleted and it's not going to cost me anything. So this is very important. Based on the demand, I can go ahead and increase the number of servers or decrease the number of servers. And flexible, if I want, let's say at this point in time I have 32 GB of RAM server. If I want, I can scale it, I can decrease it to, let's say, 16 GB. Let's assume there is not a lot of movies getting released, the traffic is low, I can decrease the server capabilities. So that's, in that way, I'm flexible. I have the option of flexibility. That's another advantage that I get if I move to cloud. Then most important thing is cost efficiency. Let's do a cost analysis between us maintaining the server and moving to cloud. So if I look at the same thing, so same specifications, how much does it cost? Let's say 2 lakhs rupees. First, this is the initial investment I have to make, and 10 lakhs, sorry, 10,000 rupees, 10,000 rupees every month, and some other miscellaneous. This adds up to, let's say, 2.1 lakh per month. So initially you have to pay, let's say, 2 lakhs, and after that 10,000 rupees every month. Now this is what you need. At least you need 2.1 lakhs to get started. But if I want to, let's say, take it to, let's say if I do the same, need a server on, let's say, cloud, I can get the same server for around, let's say, 1,000 rupees, or even less than that as well in some scenario. So see how, see the difference. Let's say within 1,000, you are able to get the same server on cloud, and this is for per month. So, but you are paying 10,000 rupees every month just to maintain the server. So it's obviously a win-win situation, because you are saving 9k thousand every month, 9,000 every month, and 2 lakhs of initial investment is not required to get started with cloud. So this is another advantage that I get if I move to cloud over maintaining my own server. Clear, or any questions till here, guys, on how exactly cloud has come into picture? What's the problems? What are the problems that cloud has actually solved, and what are the benefits that we get if we move to cloud instead of maintaining our own server? Before we proceed further, any questions, guys?
No.
Yeah, good, thank you. Now, okay, I understood, Kiran. We have discussed a lot about cloud computing. Okay, what are the problems that we have with server, and then how to, I mean, what exactly cloud is bringing to the table. I understood. Now, how do I get started with this cloud concept? So, to get started with cloud, we would need something called as, we have to choose something called as a cloud provider. Just like you have a requirement of calling someone, what you need mobile network. So you have mobile network providers like Geo, Airtel, Vodafone Idea. You have all these mobile network providers that helps you to, let's say, create a mobile network, and enables you to make calls from one place to one person to another. So that's, and in the same way, if I want to make use of cloud, there are cloud providers. So there are lots of cloud providers. So we will discuss the big three in this space. First is Azure. We have Azure. This is from Microsoft. Then we have AWS, stands for Amazon Web Services. This is from Amazon company. And the other one is Google Cloud. In short, people also call it as GCP, Google Cloud Platform. These are the three players in the market. Does that mean these are the only three players? No, there are other cloud providers like Linode, Alibaba Cloud. So there are a lot of clouds out there as well, that where we can go ahead and create our servers and run our application. Now, okay, next question is, which one should I choose? So same question, if you want to purchase a new SIM, what you would think, there are a lot of options. You would think of, okay, where you would think in this way, okay, where exactly, what's the pricing of that? That's one factor. And then what's the coverage of that, service of that? Based on that, you will take a decision. In the same way, if you want to choose between the cloud providers, I would say you choose anything. Like you can choose AWS, Azure, GCP, anything is fine. The concept is in here is you can learn any cloud and switch to any other cloud at later point in time. The concept of cloud, that doesn't really change. If you want to make a call from its iPhone versus Android, does that change? Okay, how you interact with other person? No, right? You just dial the number and it goes to the other person. That's a concept, but the interface might be different. Same concept. If you move from Azure to AWS to GCP, the naming might be different. Let's say in Azure, we might call it something like a virtual machine. In AWS, you call it an elastic instance, something like that. I'm just giving one example. So you can learn any cloud, you can pick any cloud, doesn't really matter. But we have to understand one cloud better, uh, deeply and detail. Then switching to any other cloud would be very easy. So that's why you can pick any cloud. Now, why do I get started with Azure? As a course name suggests, Azure. Why do I need to pick or stick to Azure? Why can't I go with AWS or even GCP? The problem with GCP and AWS is that you need some Linux fundamentals to get started with Azure, sorry, with AWS and GCP. But there is no problem of, or we do not have any prerequisites of doing anything on Azure. It's similar to, we have a very good portal, a very good website where you can go ahead and create any server you want within no time in Azure. It's more or less similar to Amazon trying to book or trying to order what you need. So it is easier to learn when compared to other two cloud providers, let's say AWS and also GCP, where you need some Linux fundamentals and all that. So it is easier to, it is low code. You don't have to worry too much about, let's say, coding and all that. We do have some coding, but that's not as complex as data structures and all that. It's very simple to understand if you know how to think, and will also, let's say, think in those lines of how to create something. So it is low code, not exactly or no code. It's low code. Then if you look at the job opportunities, you say it's easy to learn that. Does that mean, okay, no one is using, if you look at the stats from Microsoft, it says 80% of Fortune 500 companies use Azure to deliver their business and all that. So what exactly are Fortune 500 companies? If you look at US stock market, these are the top 500 companies that's out there. So, and you, as it's a Microsoft product, you have very good integration with other Microsoft products like Outlook or Teams, VS Code, whatever it is. It has really good integration, and it offers seamless GUI. So if you want to do anything, you can do it directly from this thing called as a portal. If you have something called as portal for Azure, you can do anything on that, and it's very easy to get started as well. So these are some of the reasons why we make use of Azure over the other cloud providers, and that's the reason why we are sticking with Azure. Okay, so far any questions, guys? So now let me just write down. So we have discussed about cloud, what are the benefits that we get by moving to cloud over maintaining our own server, and important thing is what exactly is a cloud provider, and we have looked at what are the cloud providers that are out there, and we have also justified why are we sticking with Azure. And what exactly is Azure? Azure is a cloud platform where one can create servers. There are a lot of other things that can be created, but at this point in time, let's just say it's a cloud platform where I can create servers. So that's the expectation, or that's the purpose of this Azure cloud platform where I can create servers. Now, what's our course name? Our course name is Azure Admin and DevOps, right? So first is, we have discussed about Azure. It's a cloud platform. There is one more thing, that is Azure DevOps. Now, what is this DevOps and what is this Azure DevOps? Let's try to understand it. But before going further, any questions, guys? So far, are you guys following it, or any doubts? All right. Now, we'll try to understand the other words. That's DevOps. What is this DevOps? So if you look at the formal definition, it says combination of philosophies, practices, a lot of things. So we'll not try to dig deep into this definition. We'll try to understand in a practical approach. What is the purpose of DevOps? What's the problem this DevOps is actually solving? So let's try to understand in the similar way how we have looked at cloud. So what's the problem what are the problems that are out there, and how cloud has solved them? In the similar way, we'll first look at what's the problem and how DevOps principles and everything has solved that problem. So first, before understanding what exactly is DevOps, we have to look at how a software is being, let's say, delivered to the end user, how a software is actually being built. So we'll look at that. So first, if you look at a Book My Show kind of application, you cannot really go ahead and create that Book My Show application without any planning and all that. So first thing we have to do is, you take any software application, first it has to go something called as stage one. It is called as planning, where people will sit together, whoever needs to work, they would sit together in a meeting room or whatever it is. They will understand, okay, what are the features that needs to be in place in this application, like what can be those. Let's say there should be a login page, so they will do the planning. So initial step is to do the planning, okay, how should the login page would look like, and how to make the payments, what all things needs to be done, how the UI should look like. Everything will be planned meticulously. They will come up with some strategy. Okay, this needs to be delivered by within this month, and they will come up with the plan and requirements as well. In this planning, they will also do requirements. Okay, what all needs to be placed in that application. They will come up with all the requirements in planning. Then they give those planning details. Okay, I need a home page, I need a login page, sign up page, payments page, and all that. These requirements will be given to the developers or coders, programmers, whatever you call them. So they will take those requirements and try to implement them. So if the requirement says I need a UI where people can log in, this person will go ahead and try to build that application. So that's the job of this developer, or you can also call this person as DevOps, developer, or programmer, or coder, whatever you want. Then it moves to the next phase, that is coding. Then once the coding is done or the development is done, we do something called as testing. Now, what is this testing? Why do we need testing to be done? Developer has already written the code, then why do I need this testing? So testing is also very important, as it's as important as development. So we have to test the features. Let's say developer has written some code to display a home page, or let's say login page, but that person did not check whether how exactly it works on slow internet. If this has not been tested by so there's a separate team that does this. So you have team called as QA engineers. So these people go ahead and test this application end to end. See, okay, if they give an email ID and password, is it working fine? Is it, let's say, how is it working on slow internet? They'll test each and every scenario, see, okay, whether it's working or not. If there is an issue, they would send it back to developer saying, hey, can you please look into this issue? There's if I go to, let's say, if I am on slow internet, it's not working fine. You might have to optimize your code. So there would be end-to-end testing that will be done in this phase, stage 3. Then once whole testing is done, the development is done, then it goes to something called as deployment. Deployment as in, instead of running the application on developer's machine and all that, you run it on servers, or on, let's say, cloud, whatever. I've just put the server image in it here. You can think it as cloud as well. So now that process is called as deployment, so that everyone on the internet can access it. So that process, once the application is ready, you go ahead and deploy it. And after this, we go ahead and, okay, once the deployment is done, is that it? No, you have to constantly maintain it or do monitoring. We have to do monitoring as well. As in, if let's say if a lot of traffic is coming here, how exactly the application is behaving. Is there any lag over there? Are people able to access it, or is there any crash? You have to take care of maintenance. If you get a feedback, you have to take that into consideration and try to implement the features around that. So this is how an application will be developed. First, you start with planning, then move to coding, or let's say coding phase, where developers will write code, and once that's done, testers will be testing it. And once everything is done, you go ahead and deploy the application on a server or be it cloud. And after that, you also constantly monitor and maintain the application, so that there are no outages or no downtimes for that application. So this is the whole process of how exactly we develop a software application. Any doubts over here, guys? Now I'm clubbing these first three stages into something called as development. So this is development, and the next two belongs to operations, because we deal with servers and all that. That's why it is called as operations. Now, if you look at the word DevOps, it's a combination of these two, development plus operations, where you make the collaboration between operations team and development teams. So DevOps is actually coined from these two, let's say, word, development plus operations. Now, okay, what's the problem? Everything looks great. application has been built. First you do the planning, then you give the requirements to the programmers. They would, let's say, write code. The QA engineers will test the application, and we will take it to the deployment, and it's done. I mean, everything looks great. What's the problem in here? So the problem in here is the collaboration part, because it's not just only one person will be developing the application, or a team of developers will be developing the application. There might be a lot of other teams that needs to be collaborated together. So now if you look at this example where let's take the bookmyshow example itself, where I took there are two teams. One is the developers team, or the coders I have just written. The other one is QA testers. Now let's say it took 1 month for the coders or the programmers to write code for developing the application. Now during this time, what exactly QA engineers or QA testers would be doing? They, during the process in which these people are working, let's say coders are working, what exactly QA engineers will be doing? They would be idle. Why exactly they would be idle? They can go ahead and test the application, right? Why they have to wait for the developer to finish their code? The problem is that as they are developing, let's say developers are, let's say, writing code, they are writing on their laptop, let's say developer's machine. If this tester wants to test that application, how it's exactly behaving on slow internet in a couple of other scenarios, now this person has to get access to the developer's machine, ask the developer that, hey, can I test the application that you, or the code that you've written? I have to, let's say, deliver it by next Monday, whatever it is. But developer will also have their own deadlines. Now if he has some leisure time, that person can give the laptop to tester to test it, but that's not practical. So that's a problem. Now that's why during the development is in progress, QA engineers will be sitting idle. So that's one. Then what about second month? Once let's say it took 1 month for the whole application to be developed, the development process is done. Now it moved to testing. Now during the testing, testers will be testing the application. Now what about the developers? If there is no work, if they are involved in some other project, that's fine. But if not, they will be sitting idle and they will not have any work. So but during the second month, these QA engineers will be working, and developers will be in ideal state. They will not be working, doing anything. Now if you see, there are clear gaps where you're not making efficient use of the resources, as in, let's say, your developers and also your QA tester. You are not making, let's say, RAM is not making efficient use of their potential. Like you're wasting, let's say, you're just paying them salary without giving any work, and that's a problem of RAM, because you have hired them to give work, and if you are not able to give them work, it's problem of RAM. So now what exactly is happening? Because of this dependency between teams, now developer, code, tester cannot really test, because there is no way that application can be put on their machine and they can test it. Now what's the problem in that? They have to wait for some time to get that application fully developed, then they can go ahead and test it. That's the problem. So this is a major problem with this approach, where you're doing things in a serial fashion, where work development is happening in one phase and the QA is blocked because the development is in progress. And then same thing, if QA is testing the application, then development is, let's say, blocked. So there is clear gaps and clear ways in which we can improve. So that's where, and if you look at the time taken, the application has been developed, let's say, within 1 month, and let's say testing also takes 1 month, because there might be a lot of scenarios, a lot of let's say features needs to be tested, each and everything needs to be tested. So let's say it took 1 month to develop, test the application end to end. So how much time does it take to take this application to the end user or to the internet? It took them 2 months. So because dependency between the teams, even though the application has been developed within a month, it took them extra 1 month before we go to the next phase, that's deployment. So they test whole for the whole development. I mean, they might write, let's say, millions of lines. They have to test each and everything, each and every scenario. So if you look at normal application, there might be 5,000 testing scenarios. So check whether user login is working, how exactly it's impacting or behaving on slow internet, or how exactly the search function. I'm just giving some scenarios, how the search functionality is working on low internet, a lot of other scenarios. Now, as they're doing all these scenarios at once, because once our testing is development is done, it moves to that QA phase or testing phase, where they're testing all the scenarios at once. It's highly likely that due to human nature, we might miss one or two. I mean, in 5,000, you might miss or one or two, let's say, scenarios, and that scenario might be that scenario or that problem can be detected by the user. Let's say they're trying to search something, but it's not popping up. And testing team might have missed it in testing that scenario, and it's quite normal because we are doing a lot of things at once. So that's one thing. And if that happens, we might miss some scenarios. And the problem with this is we are delivering a product, but it's not quality product. There are some issues with that. So that's the other problem that we have with approach, let's say, where we are taking a lot of time. One is, even though the application has been developed within 1 month, we are taking extra 1 month to do the testing. And even if we are doing the testing at once, there are problems with that as well. So there's a high chance that missing some scenarios, the testing team might miss few scenarios and all that. So that's the other problem. And this leads to overall quality decrement, or the quality of the product that we're delivering will be decreased. So these are the two problems that we have. One is it is taking longer to deliver the application. That's one thing. And the other thing is the overall quality decreases. Even though we are taking more time, does that mean we are delivering a quality product, quality software application? No. So there are two problems with this approach. First is taking time is one more thing. So this is also called as delivery time, or the time that we take to take it to the end user. So that is called as delivery time. And then we have the quality issues. So quality is also getting decreased. So these are the two problems that we have in this approach, let's say in delivering the application or developing the application. Now, what's the solution to this? So the solution to this is actually DevOps. So DevOps, let's say, recommend some product. Sorry, I recommend some principles and practices that we have to, let's say, implement so that we can deliver the application faster. And does that mean, okay, I'm delivering the application faster with DevOps concepts? So will I be able to, let's say, match the quality? It's actually inverse. So you actually deliver the application faster and your quality of product also increases. Now, how is that? Let's look at this. So using DevOps, what are problems that you have faced? You will decrease the time to delivery, and also you, let's say, increase the quality of the software application. And how is that possible? So if you now, what we do in this DevOps principles and with the help of DevOps principles and practices is that we plan, let's say, for a couple of weeks ahead. We don't plan for everything at once. We plan on incremental basis. We just plan for a week or so, what needs to be done, what needs to be completed within that 1 week or 2 weeks, and you take those requirements and give them to the coders. They will code the application, and once that's done, they'll immediately test. Now DevOps has this concept of creating environments and all that. Now that helps me to develop and test my application on a continuous basis. Just give me a second, guys. Yeah, sorry about that. So we were discussing this DevOps principles and practices enable me to do testing and deploy. Once the testing is done, I can take it to the end user within no time because I have complete cycle. So this whole thing is called as DevOps infinite loop. And once I take it and do the deployment, I can do the testing on the same day or same week. And once that's done, I deploy it and constantly monitor it. And once if there are any issues, I go ahead and do the planning and then give the requirements to my developers. They do the development, and then it will be tested on the same day, and do the deployment. So there is a continuous loop that goes ahead. So that's why it is called as infinite. If you look at the symbol, it resembles infinite. So that's possible with the help of this DevOps principles and practices. Now, okay, I've learned about DevOps, which solves this problem
Kiran,
because, yeah, please.
Kiran, sorry to disturb.
Yeah,
So, coming to the previous slide, I have a small doubt whether
yeah, please.
can go ahead.
This one.
DevOps concept. Yeah, no, no. previous one. Yeah, here. So so DevOps is a combination of dev and operating systems, as agreed.
Correct.
So plan, code, build, test. So this testing belongs to internal local testing or like after deployment testing.
It's basically after deployment itself. I mean, you have a couple of tests. You have unit testing that can be
Yes.
implemented in development lifecycle itself. And once it's been deployed, you can also do another layer of testing, like, okay, whether it's working fine or whether the search functionality is working fine, or some functional testing can also be done after we deploy it.
So these tests after build, these tests
Mhm.
belongs to unit kind of testing, unit testing.
Yeah, unit testing, it can be using Sonar Cube. Let's say security
So,
testing, it can be done directly from during the development process.
so this testing is not after the deployment testing. I mean to say, the application is deployed on server, and
Mhm.
after the deployment, the people will do a kind of a sanity testing. So
Mhm.
that testing is not belongs to this, right? So it is a kind of unit testing.
Yeah,
Covered.
you can think this testing as part of development, and after you deploy, you can also do one more round of testing.
Mm.
So in here, I mean, from the diagram, we just focus on unit testing, what can be done during the development process before we cut a release and deploy. Once we deploy it, we do another round of testing as well.
Mm.
So
Got it.
even if you want, you can add one more testing in here.
Yes.
So this is a standard diagram, but but the overall concept is that we do things continuously. We don't do, okay, we plan one day and then after 1 month we do the testing and all that. This DevOps, using DevOps principles, we can develop the application at a faster rate and test it. As we will be testing it continuously, we would be able to find out the bugs faster and fix them quickly. Is that clear?
Yes, Kiran. Yeah.
Yeah. Any other questions, guys, before we proceed? All right. Now we have discussed about DevOps, which enables us to deliver the application faster and also deliver a quality product. This is very important because we will be testing and developing the application continuously. So that's a major advantage that we get if we move to DevOps, if we implement DevOps principles and practices. Now, what is this Azure DevOps? So Azure DevOps is a platform that helps me to implement all the concepts that we have discussed, like how to build it, how to test it. So this platform is a one-stop solution to implement all the concepts that we have discussed. So first, if I want to do some plan, we have something called as Azure Boards. So Azure DevOps is a platform where you have multiple services. It's just like saying you have Amazon. So you have Amazon, it has multiple services, right? One is you have Amazon for, let's say, shopping. Then you have, let's say, Amazon Music to listen to music and podcasts and all. You have Amazon Prime Video to stream, let's say, movies and web series, right? It's the same company, you have different services. Same way, you have Azure DevOps, and based on the purpose and the requirement, you'll choose that appropriate service. That's Azure Boards, where one can do planning. Then we have Azure Repos and Azure pipelines to do the development, like coding and building and all that. I have just clubbed both of them to development. And then we have Azure Test Plans. So this is a testing platform where I can go ahead and add test cases and do that. And we have same thing, Azure pipelines to do the deployment. And we have something called as App Insights, log monitoring. This is not an Azure DevOps service. It is basically belongs to, let's say, Azure, but you can also club it in Azure DevOps because I want to just give, okay, what can we do with Azure DevOps and all that. So this, you can also do monitoring using Azure App Insights and all that. So I've just placed the same thing again. So if I want to do planning, I can use Azure Boards. For coding, to store my code, I have something called as Azure Repos. For building and testing, let's say we have Azure Pipelines. Or for specifically for doing testing, we have Azure Test Plans. So using the test cases, we can also do testing. So once the code has been deployed, we can also write some test cases and add them over here. So that's one thing. And don't really deep into, okay, where exactly is the position. The concept one needs to understand here is, okay, we have testing, we do the testing continuously. This is the keyword. And then we have, let's say, monitoring that we can do using App Insights. And if I want to deploy and cut a release, I have, let's say, Azure pipelines. And so far, any questions, guys? Any questions related to DevOps and the concepts that we have discussed?
Kiran, yes, I have.
Yeah, please.
So in this Azure DevOps, So
Mhm.
we are having Azure repos. So we no
Correct.
need to go with any external repos like GitHub
No, no,
repository, all those stuff.
no, no. No, we don't. We don't have
Everything with Azure only.
everything is Azure DevOps. We have everything. You don't have to, let's say, go to Jira to maintain your tickets and all that. You have Azure bots. So that's why I mentioned it's one-stop solution to implement everything related to DevOps.
So creating project, maintaining everything is on only Azure.
Everything that you can think of delivering a software, you can do it directly from Azure DevOps.
Okay.
Yeah, does that answer your question?
Yes.
Okay. So now a lot of people get confused between Azure and Azure DevOps because the naming is like that. So easy to get confused. So I just want to make more emphasis, let's say, I want to, let's say, reiterate one more time what exactly is the difference between Azure and Azure DevOps. Azure is a cloud platform where I can go ahead, create servers. So that's the purpose of creating, or that's the purpose of Azure, which is a cloud platform. Then I have my Azure DevOps, which is a DevOps platform where I can implement DevOps principles and practices, like storing my code, creating pipelines. We'll discuss, okay, what are these pipelines as we go on. But for now, I'm just giving, okay, what's high level difference between what is Azure and what exactly is Azure DevOps. So if someone asks what is Azure, it's a cloud platform where one can create servers. And what exactly is Azure DevOps? It's a DevOps platform where I can store my code, create pipelines, and all that. And is Azure DevOps the only DevOps, let's say, service of that? We have other services as well, like GitLab. We have GitHub Actions, but they have their own limitations as well. But in this course, we'll be focusing on Azure DevOps. Now, let me go through a high-level overview of what are the concepts and how this course is structured. First, we'll start with Azure and go about cloud computing, what exactly is server, and discuss concepts related to Azure, networking, a lot of things. And once that's done, we try to automate whatever we have learned in Azure using something called as PowerShell. So PowerShell is something that we discuss like from scratch, so you don't have to worry, okay, now does that mean I have to know some data structures or some background around coding? No, I would say no need of that. It's very simple. It's basically a scripting language where everything is laid down. You just have to know how to put those pieces together. So that's very easy to learn when compared to, let's say, coding languages like Python and all. So that's one thing. And then how we have something called as IAC, stands for infrastructure as code. We'll implement the same thing using ARM templates. And one more important thing, that is Terraform. We'll go in detail when it comes to Terraform and all the concepts that I have put in here. So and if you look at any DevOps interview or cloud interview, they ask questions around, let's say, Terraform. So Terraform is must and should. So we'll cover that as well. And then we'll implement DevOps using Azure DevOps, write YAML pipelines as well. And if required, we'll also look at open source tools like Jenkins. And once all of this is done, we'll also try to take things, let's say, try to understand what exactly is Docker, Kubernetes, how to deal with, let's say, deploy an application in Kubernetes, how to maintain, and learn a lot of concepts related to Docker and Kubernetes. So this is a brief outline of what we are going to discuss, and we'll also implement, let's say, DevSecOps. That's another buzzword that's out there. So where we emphasize on security, of implementing security while doing the development in our pipelines and all. So that comes as, let's say, DevSecOps as well. Okay.
Uh,
And what? Yeah, please.
Kiran, so coming to the outline,
Mhm.
so this Azure and cloud platforming. So we'll be discussing about the infrastructure part as well, right?
Yes. Mhm.
Like
Please go.
like from scratch to the things like how to maintain application and roles and responsibilities of infra
Mhm.
guy. So
Mhm.
this covers those also, right?
Correct. So everything will be practical. So what we do is we take an application, we try to deploy it onto Azure. Then we take it, try to automate and deploy it manually. Then we'll look at how can we automate using pipelines. And then we'll look at how can we do the same thing in YAML. And then take the same application and take it to Docker and run it as, let's say, pod and Kubernetes and all. So we take it in a practical way. Everything is in an ordered fashion, and we'll go in depth in understanding each and every concept, and we'll start from scratch.
Mm, mm. The reason for question is like so
Mhm,
I was like very blind about the Azure, and I
mhm.
doesn't have any knowledge on Azure and infrastructure part as well. So
That's fine.
I would like to learn from like infrastructure to deployment part.
Yes,
So
will our goal is to, let's say, uh, make people understand from scratch. We'll not go ahead and think that, okay, people have some knowledge. My expectation is that no one knows anything, and even we'll try to, let's say, deliver the lectures or whatever it is in that fashion. We'll start from very basic, absolute basic, like what exactly is a server. So that's why we emphasize on, let's say, basic, getting the basics correct, because I've seen a lot of people getting the basics incorrect and they struggle a lot. So that's why this course is curated in such a way that we'll start from scratch, try to understand concepts to in depth, and then we'll build on top of it. So it's not like, okay, we'll go ahead and try to finish the syllabus. That's not our goal. Our goal is to, let's say, improve the skill of the person who takes this course. So that's our main goal.
the application deployments, like we used to deploy multiple applications, or like only we'll go with the Java, or do we deploy like Angular applications as well? Like
We also deploy React.js application and .NET application. That is more than enough, because if we keep on covering all the applications, then it would be like spoon fed. So what we discuss is, we discuss the concepts in such a way that this can be implemented to any, irrespective of the tech stack. If we discuss, let's say, one or two, we'll discuss one, two, and which is good enough to cover all the bases. And we you can take that knowledge and do the same thing for other tech stack, like Python application, or be it Java application, whatever it is. You can take that knowledge and implement the same over there as
okay, okay.
well. Does that answer your question?
Yeah, so we'll be deploying a limited kind of technology applications. I do agree we cannot go with each and every
Mm.
technology deployments.
But I can guarantee you that whatever we discuss, that can be implemented, and whatever knowledge you get, that can be easily taken to other tech stacks as well. So there is no doubt about it. So is that clear?
Yes, yes, clear.
Yeah. So what are the expectations and how much time does it take? So we to take around 60 to 65 hours of classes. So to finish the complete, let's say, concepts that we have outlined, and everything will be hands-on, as this is the introductory session, just to lay down, okay, what are the concepts and what exactly is cloud DevOps, and what are we going to learn. Have just taken slides and explained it, but everything will be hands-on and practical, so that anyone can, without any knowledge related to DevOps or cloud for that matter, can understand and follow up the course. So that's the expectation, and everything will be hands-on. We'll be giving, and the class will be recorded. Usually, it would be from Monday to Friday, 1 hour of same class from 8:30 to 9:30, and we will also have a real-time project that will be given as an assignment for evaluation at the end. Just give me a minute. Yeah, coming to the class timings, we'll start at 7:30 to 8:30 starting from Monday. So this is about what we offer and what's required from your end. So whoever takes up this course, we would require you to focus, and if you and try to do the practice as well. It's not that just attending the session and doing, let's say, just listening to the session and feel that, okay, I've learned something. No, you will definitely learn, but if you want if it to become a concrete material so that you can crack an interview and get a job, then you would need to do the hands-on. So you have to spend some time doing the hands-on what we do in session, and we'll also give some tasks and assignments wherever it's required. So it's important to do the hands-on as well. And most important thing is ask questions. I've seen this session with a lot of questions and doubts. I want that to continue. So please ask questions, doubts of wherever you get stuck. Even if I use a word that is a bit, let's say, difficult to understand, that's fine. You can just straight away ask question, or just unmute your mic and ask question. I'm more than happy to, let's say, answer that. And if you are shy and don't want to just unmute your mic, that's completely fine. You can put it in the chat, and I can, let's say, answer it as well. So I'll be monitoring the chat as well. So don't have to worry. Just put it out there and I'll take a look and also explain the concept. So just be let's say focused, whoever takes up this course, and try to do practice. And these are the expectations from our end. And please try to ask questions, doubts, whatever it is. Yeah. Any questions, guys? That's
Okay,
pretty much it from my end. Yeah.
Kiran,
Please.
one thing.
Mhm,
Sorry, so I don't want to confuse people. Just
mhm,
my personal experience, I have something that which I
mhm,
have to share. See,
mhm.
I have seen many of my clients. We are a product-based